Today we're going to start on talking about loading and the powertrain, and then in the following weeks we'll cover cornering and other instrument handling. So today we'll just look at the forces on the car. We'll talk about static loading and some of the equations you can use to come up with that. It's nothing too taxing, it's all basically level 1 dynamics, applying Newton's laws. Look at dynamic loading on the car, and then also talk about tractive force and the powertrain relationship between. What about dynamic loads? Well, let's have a look. Okay, so we've got the same vehicle picture. Okay, this time we've got some loads being applied to the tyres. So those are the moral resistance. They're in the negative x direction in a sense because they're resisting loads. Okay, we've also got a aerodynamic drag at the front. Okay. And clearly, if the vehicle is accelerating, there's an inertial load, which is a resisting load. Okay, if you think about it. As you accelerate the car, you're going to get a force that feels like it's pulling backwards on the car, which is the inertial. Okay. And clearly, the attractive force has to overcome all those ones. If the car is four-wheel drive, then obviously you've got attractive force at the front and at the rear. Okay, and those two positive x forces, these two here, have to overcome all the negative x forces. So mx and we've got fa, and then the volume is pointing back. And so if we do some taking moments about the rear tyre contact patch again, we've got similar sorts of things going on. Okay, so NF, L, positive x, positive direction, anti-clockwise. Okay, well FA times by the H, which is also a positive thing. Okay, we've got MX times by H. Okay, also in that direction, and then we've got MGH sine of theta, which is in the MGD cosine of theta, which is in the negative direction. Okay, and MGH sine of theta, this one here, is also in the positive direction. So you've got these equations, okay? You can then solve for the front load just by isolating this term and then by the engine by air. So now, because the thing's moving, we've got an aerodynamic force going on in here, okay? We've also got a force due to the acceleration of the vehicle. The reason why the Roller resistance doesn't appear in here is that we're taking moments about this point, and clearly a Roller resistance here and here has no effect on the moment around that point. So that's not included in the calculation. The Roller resistance does not affect the loads in the car. So I'll write this one out as well. Okay, so these are static. Okay, static. Right, dynamics on there now. So NF, that's ZR, isn't it? MGD, cosine theta, minus MGH. Okay. Take a moment on the front tyre contact patch. Okay, so here's the moment of this point here. Okay, so again, the roller resistance is taking into account. In the negative x direction, which we said is clockwise, we've got NR times by L. Okay, that's negative. Okay, cross FA times by H, that's in the positive direction, which we said is anti-clockwise. MGC cosine of theta, and there's our MG cosine of theta times by the distance c, again in the positive direction, MGH sine of theta, okay, well that's this direction, okay, times by h, which is also in the positive direction, and then mx double dot times by h, which is also in the positive direction. So they're all plus, the only one's minus is this side, so clearly when I rearrange it, okay, they equal each other, they're both positive, oops, let's go here. And so we have our NF equation. So that's mg c cosine of theta, okay, plus mg h sine theta, plus fa h plus m x double dot h divided by l. Okay, so in-class question 2. If the car in in-class question 1, okay, is given an acceleration of 4 meters per second, determine the new normal loads on the axles, ignoring aerodynamic drag. Okay, so we're going to say FA is 0, just to save complication. Okay, but I will now want you to use these two equations to show the difference the acceleration makes. So in-class question 2. So it's as above with the acceleration x double dot equaling 4 meters per second. Okay, and so we've got NF mgd cosine theta D is 1.2. Okay, we'll divide it by 2.6. And if you do that sum, $6,213, so you see it's gone down from before. And NR has gone up correspondingly. If you do that sum, that comes out to be 8,000.